Hey everybody, it's Nick for today's tutorial. It's another kind of introduction to some of the core concepts of Grasshopper, and the topic is going to be parametrics. And we're not going to be looking necessarily at making objects parametric. We're going to be going, like I said, to some core concepts. We're going to be talking a lot about the different ways that we can get numbers into things in Grasshopper as sort of like an input. Remember, everything in the computer is essentially like voltage, right? It's like ones and zeros, and those become numbers, and we use those numbers to make things, right? We can have a number that is that represents a value. We can have a number that translates to a letter, and we have strings of letters that are words, et cetera, et cetera. And of course, we can have numbers that are the coordinates of something, or how much of something, or how much something costs. And so, like everything, all the way down can be represented as a number. It's probably the simplest way we can describe something. And so it's important to understand how to work with that um, when you're doing things in Grasshopper. And we did a lot of things last time with like the number slider, if you remember. And we had like a cylinder. And so we had lots of different ways to get um, a number slider into Grasshopper and to use that as a parameter, right? And you've heard about parametrics before probably, and you've probably heard about the term parameter, but in this case, what we mean is just any kind of value that represents some information that's in like a design. Okay. A parameter in this case, could be the radius of this thing, right? It could be the size of something. Again, it could be how much something costs, and they're all kind of. And the thing about parameters is that they can be like related to each other, and it's those relationships that are actually really like interesting, and can become really important. And that's where we can make things intelligent and we can save a lot of time and hopefully a lot of money on some things. And so that's why. And the thing about parametrics, right, is that they change, right? You can have a parameter that changes, and also you can have a parameter that responds to something. So if I have an input, I can have a parameter at the end that like changes. Okay. So this again, let's go back to our friendly cylinder again, and let's just use this to look at a couple of different things, and then we'll kind of make something more interesting with that. So right away I've kind of made this sort of like component, and you can make a number slider if you go to the first panel, which is called parameters, and you can go ahead and drop it in under the input tab. One thing I want to note too, if you're coming to this video from another school or another time and place, I have a lot of plugins up here. And yours will definitely not look like mine, your computer interface. I'm also running Rhino 6 right now. Rhino 7 is out, but we're not running it because a lot of people are still using 6. And so things will probably look a little bit different, but I'm hoping that the behaviors are still pretty similar, and the concepts most definitely are. So all that aside, you put a number slider in, and remember we can like actually edit the number slider. We can right click and we can say edit, and we can change the minimum, change the maximum, that kind of thing. I'm gonna go ahead and just put in some simple like parameters here. Um, and you plug it in for something, some value. The other thing you can do, remember I talked about in the first video, is you can double click and you can say number slider, right? And you can do that. And that's handy because I don't usually like to hunt for this kind of stuff. So there's two ways you can do that. There's actually a third way. And this is something you'll see a lot if you're watching other people's videos is you can double click and you can actually put in a number. Like I can say 10. And that'll give me a number slider that goes from 0 to 10 by whole numbers, which is kind of interesting. Um, you can also do something, it varies. Like, so if I do 100, I get a number slider that does that as well. Okay, so that's nice if you do things by 10 or by 100. It's by whole numbers though. You don't get any kind of decimals or anything. You can change that of course, but that's kind of a handy shortcut for those kinds of things. If you do something like let's say 5, you'll actually get a slider that goes from 0 to 10, both 5 in the center. And let's just go again. If you do something like let's say 30, you're going to get a slider from 100 to 0, but it started at 30. So that's kind of a shortcut to things. Like if it seems like I'm not exactly sure how the logic works, but the way that I've kind of understood it is within those if it's from 0 to 10 or 0 to 100, well, sorry, if the number is larger than 10, then you get a slider that goes to 100. If it's less than 10, then you get a slider that goes to 10. Um, and by default, you get a slider that goes from 0 to 1. So that's kind of a handy shortcut if that's a range that you're interested in. The other thing you can do that's even better is you can actually create one. You can bust out your math skills, and I could say like I want a slider that goes from -5 to 0 to +5, and that's what I'll get. And that saves you a lot of time instead of having to go in, click on this and like edit it and all that stuff. So that's something you'll see a lot of as a really really handy kind of shortcut. Okay. So there's that. So that's really useful because a lot of times you'll think of a range of like possibilities that you want for that parameter, and that's the logic that you build into it, right? So when you have a parameter, you have what you think is kind of a range. You also have a name for the parameter, and the names are really important. And Grasshopper is nice because if you plug something in, it'll automatically basically take on the value of whatever that is. And remember, if you go into full names here, you'll see that. It's actually interesting that if you do this, that it will change to number slider. But if you go without names, you'll do this. Okay. Which brings up something else. If you want to change these things, which is often, you can right click on it and you can call it cylinder radius. You can type on whatever you want. And you can say, well, like, why would I want to do that? Well, it's very important because every time, if you name a variable, that means that you understand what it is, and it means that somebody else understands what you intend it to be. Remember, a lot of times you're going to be giving code to somebody else. You're going to be giving a script to somebody else. And if you get a script from somebody, it'll be very helpful if you know what somebody wants. Um, and so it's very useful to go ahead and it's good habit, just like naming your layers in Photoshop or naming your layers in Rhino, which I know you all do, right, to stay organized, to make a habit of going ahead and actually editing them. I actually feel a lot of times like some of the variable names that come in by default for things in Grasshopper don't make as much sense as they should. For example, you have the radius, which is like fine, but in terms of this, like I don't really think of cylinders in terms of how long they are. I think about cylinders in terms of their height, right? And so that's something that you should really consider is like giving something a name that makes sense. Getting something a name that is something that you kind of agree on with your team is something that can be really really useful. And my thing too is that even if you don't think you're going to work with somebody or you don't think that you need to, a lot of times with code, especially as code becomes more complex, you will forget what you were doing, especially if you come back to it like months or years later. So it's handy for yourself to go ahead and name things, name your parameters, so you're certain of like what those values represent in your design, and it's just going to be super helpful. So again, just to recap, what's a parameter? In a design, a parameter, is any kind of value that I would say is relevant to a design. Most of the time, those are inputs. We think about the dimensions of something, or we think about what something is made out of, or what color it is. It's any kind of information about a design that's like meaningful. And naming those parameters, allows you to operate on them as like things. Instead of it just being a number like 1.22, it's the radius. And I know that seems like really, really like simplistic or whatever, but it's actually like a really important concept. Because as we'll get into the next part, if you start to name things, then they can also be like variables. Like you have a number now that you can operate on as an object, and that allows you to do things like computationally with it. And it's also just helps you like communicate about the things that you're designing. Okay. So yeah, so there you go. So just as a sort of like a quick reminder, there's different ways you can make your number sliders. Number sliders are the most common kind of like parameter that you'll find because they allow us to vary these like values graphically. Uh, and don't forget also you can like double click on them and you can change what the inputs are. There's different things too that you'll kind of get into. You can actually change the way that like the grip works on these things. You can let me get back here. Yeah, so there's different settings for this. You can change the number of decimal points, as I said. So there's lots of different things. You can also, we'll kind of get into this later. You can actually put some math into this. So I could take the value of whatever's in here and take it times two. So x times two. X, when you do times, it's actually the asterisk. So shift 8. So x times two. And so now we've like doubled. You can see the values doubling. I prefer not to do that, but if you need to kind of make a quick like correction to something, you can add a formula in there. So that's what that means. The rest of this you probably don't need to worry about too much at this point. Let me just take a look at some other things here. So you can also change the values. You don't have to go into this here. You can actually go into some of these things and actually change them here. Um, yeah, I think it's probably, you can like disable it, enable it. Those are things I don't typically like mess with very much. These are pretty standard. Okay, so that's kind of a good kind of finishing point for this little chapter or whatever in this lesson. So if you want to take a break, you want to take notes on that, this is a kind of a good stopping point. Okay, we'll like catch up just after this. All right, so where we left off, we had just talked about parametrics. Now I want to get into some of the things that are have to do with how we represent and how we talk about parametrics. You've probably in math class, talked about it like an algebra, where you have a symbol that represents something. So we just had this example where we did a formula for this. We did like x, times two, right? Well, x in this case is a variable, right? It's is as the value. Let me show you actually. As the value of this changes, right? You can see the slider as the value changes, the other value changes, right? So there's this relationship now between what was in the slider and what we've done to the math of that, right? And that's kind of powerful. So to take a step back here, so there's different things you can do with parameters when you think about them as variables, right? So this is a variable because the quantity can change. I'm gonna get this. This is kind of small, or this is not very big, I guess. Um, so you've got these variables and they have ranges. Yeah. So a variable is anything that can change, right? Basically. And they're represented, instead of x, we've called these height, we call these radius. That's fine. Um, and so you can have, and that's one of the most common things. And there's different things you can do with them. So right now, these are independent from each other. These are independent variables. So if this one changes, it doesn't actually do anything to this one, right? But because we have math, we have these things, we can actually create a dependency on these things. So you can do this in a couple different ways. So I can actually plug this one in for the length, and I think you saw me do this before. So now these are actually like dependent on each other. As this one changes, as the radius changes, the length changes, and they're the same actually. Okay, so you get something that's basically, yeah, the same in this. The radius is equal to the like height. Okay. But what if you wanted to make it so that they were actually that the height was equal to the diameter? So you could take the radius and you could divide it by 2 and then they'd be equal. And there's different ways you could do that. You can right click on this, you can go to expression, and then you can say like x divided by 2. And the variable that whenever you're doing one of these things, it's always x. Doesn't matter like what the input is, it's just use x. So x is whatever this is, okay? So take that, divide by 2, and so now we've got something where the diameter is equal to the height. So it's different than it was before. You can see the way that grows is kind of satisfying, right? See the little asterisk here? That means that there's data that's being processed differently, and that's your cue that something's happening. So it says x divided by 2. Okay. You can do this. Obviously, you can because I just did it, but I don't prefer to do it as a designer because I think burying things inside of these components um, is not it's not very transparent. Like if somebody's looking at it, they may not really like look at this to know what's going on. Um, and also, it's not easy to modify. So if I want to change it, I have to go in and like right click it and like change this thing. Like let's take it off. Okay. So I don't really care for that very much. And it's even worse when you have like this kind of thing, which is the way a lot of scripts are because it makes them smaller. So what I prefer to do is something else. Go ahead and take this off now. Just delete it. Okay, now it's gone. There's all kinds of math components that are actually built into Grasshopper. You can go over to the math tab, maths. You can tell it's very European. You have all these operators, polynomials, things like that. This is where it gets kind of scary. But here's where most of the ones I use are. You can do any kind of math you want. You can have addition, multiplication, division, etc. There's also an expression component, which we'll kind of get into, which lets you do really complex math. So for now though, like to do what I did, I can just do division. Yeah, you get close enough. Division, and then I can plug this in. So now the input A is this, it's A divided by B. Okay, and I can do two things. I can either put a number slider in if I wanted to, like I just did, and I could set this to 2. And so now I've got this relationship, right? So I've got this is going to be divided by 2. Remember, as I increase this, now I've got fractions. Now it's a quarter. It's 1/4 of whatever is inside of here, right? Um, or a tenth. So now you've created a proportion, right? You have a dependency created. So as this variable, it's the combination of this variable and this variable that actually make the final radius, right? You could say that the radius is dependent on the length, right? So like as the length changes, the radius changes, or like vice versa. Okay. So that's a dependency. And again, this is transparent. So I look at this now, and actually I've given myself a little bit of flexibility because what if I want to change those proportions, later, right? 1 to 1, 1/2, 1/3, that's kind of powerful. I might not do that like very much though, right? So another thing that you can do, delete this, is you can add a number. And this is a number container. Any of these things under parameters are like containers. They can store variables, they can store information, and this is one way to get things from Rhino like into Grasshopper. But this is just a number container, and right now it doesn't have a number, right? I can plug it in here, and the way it works is you right click it and you can say set number. Oops, and you can say 2, and now everything is happy. Okay, this number is just, if you mouse over it, is 2. Okay. What I don't like about this is that it's not really visible. Like you can't, even if I go in and I draw the names for things, nothing really happens here. So in order to really make it useful, you have to really rename it. So I will sometimes just name it whatever the number is. Let me see if I can get, yeah. So if you don't have icons turned on and you use a number component, number, it says number, but then if you rename it to something, it's a number. When you change this name, it actually is, it's the name of the, it's the name of the variable. If I make this 3, for example, it doesn't change this. It's still 2. So that's not like great, right? Because now you might look at this and say, "Oh, that's 3." But no, inside of it the number is 2. Okay. This is just a name. So you could call this like I don't know, half or something. Remember, it's just a name. So I have to say I like using this just as a programming style, but it's probably terrible. I should probably stop doing it because again, if you want to change the number, you need to change this. This is the only thing that actually changes the design. It does not agree with this. Okay, but that's one way to do that. I'm gonna get rid of this. I'm not using it right now. Um, but there's a better way. So I'm gonna delete this. Okay. The next thing you can do is there's a thing called panels. And a panel is this yellow kind of scribbly pad. And to edit a panel, like it says double click, and I can put 2. Okay. And you plug it in, and that is the number 2. So now it does what you want, and we can visualize it, and it actually looks like the thing that it is, right? If I change this number to like 4, it behaves like a 4. Okay. And panels are useful because it's a way to visualize things that are in a design that are sometimes really difficult to see. So you can think of it as kind of like a I don't know, like a microscope or a scanner or like whatever. They're really really useful. So I can so that's just like the default behaviors. I can type this in. I can also like in a panel I can just put it down and I can say like this is a tutorial about parameters. And this is just a way to leave a note in things. And it's really handy to do that, especially if you're working with somebody. You can say like, okay, this is what this is supposed to be doing. This is what you need to be paying attention to. You could also leave somebody a warning and say, hey, don't change this number. Um, you can. It's also handy, like I said, if you have to quit working on something and you have to come back to it, you can leave a note and say like, hey, this is what you need to fix tomorrow. So it's very useful. You can also change the name of it. You can say like, note to self. Okay. And you can do things like you can do all kinds of things with the text. You can align it. You can change the type. All kinds of stuff. You can also change the colors of things. If that's what you want. If depending on your firm's like style. By default, they're usually yellow. I'm not sure why these are green. I probably changed something, but anyway, it's a way to kind of leave these things behind, but they're extremely useful because as you can see, they have an input and they have an output. So you can leave them as notes. You can use them as inputs. Um, you can all we'll look at some more stuff later, but yeah, you can use them as inputs. You can also use them to kind of understand like what something is. So for example, like let's say we wanted to find out like the like cost of the cylinder or something. We could make an expression, right? And an expression, this seems really scary, right? But this is basically like you can write algebra in here. So you can double click and you can say like x times 100 plus y times 300, and that creates an expression. Okay, and there aren't any. Let's see here. So what you do is you can plug in says variable x, variable y, and I'll look at this in a second. So I can plug in, let's say, this value for the x, and I can plug in this value for the y. Um, oh, yeah, and I need to actually rename these. That's why. So we can just call this x and call this y. Oh, my math is bad. Sorry. Just do this. Sorry. You can't express it that way. Yeah. So if it says no syntax errors detected, then it's happy. I forgot it. Sometimes, yeah, I'm thinking of pure algebra. So it actually follows operators. So it'll multiply these first and then add them together. If you're uncomfortable with that, which I usually am, I used to just put them in parentheses. But you can do any algebra you want in this thing, and it can be very complicated. You can also do anything from that you're used to from like your graphing calculator. I can do sines, cosines, like all this stuff. We'll look at this later, but just FYI. So what I can do is I can say like, so if I rename these variables, say x and y, and you can name them anything you want, you get your results. And you can take a panel, and remember you can just make panels this way. I can go in and I can call this, cost. And so then what I can do with this, I'll just kind of stick this up here. I can adjust this and I can say, okay, how much is this thing going to cost? Right. So you could say it's like $3,500. And the idea here is that like this variable, right? Y it costs $300. So you can say that like what we're considering the length, right? Because this is plugged in for the length. It costs $300 per unit of length and $100 per unit of radius, right? And this is very simple. We could go to a client and we could say like, okay, so this is the cost of this, I don't know, grain elevator or some kind of cylinder. Maybe it's a column or something like that, right? But you can so this in this manner, you have like the form and you have like the resulting, kind of cost, right? And so, panels are great for visualizing. You can use them as inputs. If we want to go back and say like, I'm going to change the proportions of this system, you can see that that changes the cost. Okay. And they're great for like leaving little like notes for things because it's you really when you get into computation because things are usually not visible or they're being processed in ways that aren't visible. It's very critical to leave notes for things to say like this is what I'm doing or this is what I want to happen. Um, and so on and so forth. And then also yeah, so information you can use them as inputs, you can use them to visualize an output, right? Just to say like what am I actually seeing? And you can use them in different ways too. If you plug them in for other outputs, it'll just say like, okay, what I got was a surface. That's what's actually coming out of here. So it's just taking this information and showing it to you, because otherwise I have to mouse over it, right, to read it, and I don't like doing that either. I'm gonna change this back. You can always take this thing, and use it for something else too. Like it's not, excuse me, it's not really anything precious. It has an output, right? So I could take like for example, just make a rectangle or something. So let's make a rectangle. We'll talk about these later too. All sorts of things. So there's a rectangle, and I'm gonna move it over here. Just making a point object, and I'm gonna place. So I have a rectangle now, and we're gonna extrude it. Extrude rectangle into Z. And yep, there we go. And plug this in for this. Huge. So let's go ahead and reduce this by. Now, sometimes you don't care. Like, if you want to put some math in, you'll never change it. That's fine to do this. So I'm going to divide this by like 100 because it's huge. And so, like, let's pretend like this is a bar chart or something. You can say, like, okay, as the cost of this thing increases, this thing's going to get higher. It's going to cost me more money. So it's kind of like a graph of how much it's going to cost, right? So I've created a dependency from this variable to this rectangle that I'm like extruding. Okay. And I just did that just to show you that. But so like again, you can have things that are like dependent on each other, right? So like as one thing changes, it gets modified, right? We can visualize it and we can use it to like drive something else, right? So we have things that are dependent. We have things that are independent. So for example, like this number right now, nothing is able to change it. It cannot change, right? It's independent of the rest of these things. You could also say that this is independent. Like this is nothing else is affecting it except for me. Okay. But this is a variable, right? Because it's varied, like I can change it. Somewhere down here, I mean, you could consider this a variable as well, because now the cost is being driven and the cost is now actually changing the size of this visualization that I've created, right? This like crude kind of bar chart that I've created. So you can say it's also a variable, right? And it's an output. This number is a constant, right? Because it's not changing. You've heard of constants before in math class. Think about like pi is a constant. Pi is just a really long number. It never changes. And in fact, yeah, I can throw some pi down. So there's pi, right? And let's see what does it just say pi or does it give me a number? It just says pi. maybe I can, anyway, so there's, anyway, so there's a, so you can, pi is actually a constant, and you can multiply it, but it outputs as like pi. And doesn't change. The speed of light doesn't change, right? The constant force of gravity. Those are all things that don't change. So like there are some things in your design that just are, right? And another thing that might be, well, I mean, I think like the cost of things do change. I was gonna say if you knew what the cost of something was, then you could, or maybe okay, something like the one of like the dimensions of lumber or something like that might be, because that's a fixed quantity, right? So like a 2 by 4 is like you know, like 1 3/4 inches on one side. That's never going to change. If it did, that would really mess things up for people. Okay. So going back through things, right? We've got, um, and there's another thing I'll throw out too. You can use panels. You can also do something called a scribble, and it's a little note. So you can double click me, and you could say, you know, variable, right? I can leave a little note, say that like this is a variable, and you can copy paste these. And I can say this is a constant. And you could say, let's see here, this, let's see, this is dependent. It's a dependent variable. Not sure how I can get those to, I guess that's all I can do. You're really limited. Scribbles don't let you do things like whether they're centered or not centered, or colored or not colored. So they're just very very basic kinds of things, right? Constant. You could actually call this one. This one might be an independent variable. Fun. Okay. So like where else do we have dependent variables? I think we could probably say that the cost is a dependent variable because we're using it, here. Um, on one hand, I mean, I guess this is a dependent variable, probably. Yeah. Okay, so just, we sort of had a review just now of different things. What I want to kind of go back to again is to say, okay, so there's different ways to get numbers in. We can get numbers in from the slider. We can get numbers in from the panel. We can get numbers modified from equations of things. We can change numbers, by adding some math in. We've got all these math operations that we can use, and these are nice because they're really really clear, right? I could make one of these things and make it like analogous. Ooh, yeah, to double click that, and I could say like x divided by y. It's basically this, but that's kind of overkill, right? Especially if I know that this is all I'm going to be doing. And you can also do math if you embed it um, inside of the expression for the input. Okay. But again, that is I don't always like doing that because it kind of hides it from people. But if I know that that's something I'm always going to be doing and I'm never going to change it, it's acceptable. Um, yeah. So there's all these different kinds of things. Don't worry about what I did here. That was just kind of for fun. But so you can see how like once we have this put together, we have this logic, we have this like system, right? And again, now we can kind of experiment with different things, and we can see what they look like, and we can take information like out of them, and we can put that information like back into some other part of the process. It's still linear. It's still driven essentially from like just the radius, and it ends up being a cost, or it ends up being a visualization of the cost. There's none of this is going back, and influencing this in any way. It's just downstream. Just still like I talked about in the very first lecture. You always go from inputs to outputs. We do have two outputs in this case, maybe three, right? We have the cylinder, we have the cost, however we want to visualize that, and we have this kind of simple graphic that we created, right? Um, So we can do that. We can have multiple outputs downstream, right? But we just again, these don't really affect anything else. They just kind of stand on their own. And of course, you can always turn off all these different things. And so we don't if we don't want to look at that visualization again. Yeah. So again, that's just a summary of some of the terminology that we use. If you've heard about parametric design before, that's essentially what it is. It's saying that like we have something that's a value that we're keeping track of, and the values can change things within the system, and they have results. So um, a parametric, system is essentially a lot like this equation, right? You have something and you modify it, and you have other parameters, and then you end up with some kind of outcome, and that's all there is to it. But of course, there's tons of things you can do with that. We're only kind of getting started with it, but that is some important vocabulary that I want you to be thinking about, and I want you to be aware of, especially like as we're learning this, but then later on when you start to design things, because these are a lot of the terms that we'll use, and hopefully it's a little bit of like review from your math classes from like algebra or something like that. But yeah, so that's the lesson I want you to pick up from this, just in this piece. And next time we'll start talking about like how to get um, sequences of numbers, which are really important. Right now, we're only dealing with like just limited quantities. Like we have one number and we're modifying it. Um, but of course, we usually work with more than one thing at a time, and so we have to find a way to deal with lots of numbers simultaneously. Okay, so that's where we're going to pick up. Go ahead and review this, and I'll catch up with you later. Thanks.